So when you think about single-length golf clubs today, one-length irons, I mean, one name just completely dominates that conversation.
Oh, absolutely. It's Bryson DeChambeau.
Yeah, the scientist. His whole analytical approach, plus all that success in the 2010s, really just, blasted the concept into the mainstream.
He is, without a doubt, the modern face of it,
You call
the
it that.
catalyst.
Yeah.
But what's so incredible, and I think what a lot of people miss, is that this idea isn't some gimmick from the last 10 years.
Not at all.
It's almost a century old.
And that's exactly what we're doing in this deep dive. We're going to trace this whole revolutionary idea back nearly 100 years to a forgotten originator.
Mm-hmm.
And here's the kicker we found for you in the sources. The first major figure to really embrace this idea of near-uniform irons was arguably the greatest amateur golfer of all time,
A true legend.
Bobby Jones.
It's such a powerful historical thread, because if you ever question if this concept can work, we have proof that the basic idea worked at the absolute highest level of the game, way back in 1930.
Okay, so let's unpack that. I mean, how did a golden era icon basically predict a modern tech trend? And what were the huge failures that happened between his success and DeChambeau's breakthrough?
To really get what Jones did, you have to put yourself in the 1920s and 30s.
Right.
Club manufacturing back then was, well, frankly, it was the Wild West.
Meaning there was just no standardization at all.
None. Club makers would have shaft lengths that varied by several inches between, say, a 5-iron and a 9-iron. And on top of that, the materials were crude. There was zero consistency in weight or balance, or even shaft stiffness from one club to the next.
So as a top player, you weren't just fighting the golf course. You were fighting your own equipment. Massive, uncontrollable variables in the tools you were using.
Exactly. And this just drove a guy like Bobby Jones, who was so methodical and intellectual, absolutely crazy. The sources show he approached golf almost like a physicist, trying to eliminate every variable he could.
So he went to Spalding.
He did. He asked them to make him a custom set of irons.
Mm-hmm.
And this was the clear precursor to everything we see today with single length.
But we should be clear here, based on the tech back then, his set wasn't mathematically identical like a modern Cobra set is.
That's the key distinction, you're right. They couldn't do that in 1930. But what they could do was build a set with minimal variation in length, far, far less than anyone else was using. And they balanced the clubs to have a consistent swing weight.
So the goal wasn't perfect engineering, it was, forcing a consistent setup.
That's it. It was
Yeah.
about forcing himself into a matching setup and posture for every single iron shot. The genius wasn't in the metal, it was in the philosophy.
A philosophy of pure consistency.
Absolutely. Jones believed, he argued, that if he could have one ball position, one setup, one swing arc, he would reduce the mental load and just perform better under pressure.
And we have the ultimate, the irrefutable proof that it worked. In 1930, using this set, Bobby Jones wins the Grand Slam. The British Amateur, the British Open, the U.S. Open, and the U.S. Amateur. All in 1 year.
The only person ever to do it. It's the ultimate validation. He proved almost 100 years ago that the concept works at the highest level. And what's so amazing is that Jones retires right after that Grand Slam, and the idea, it sort of retires with him for decades. It just goes completely dormant, a footnote.
It's like the traditionalist side of golf just took over again and everyone went back to the old variable length system. So when did the idea finally pop back up?
It took a long, long time. We're talking the late 1980s.
Yeah.
And this was the first real commercial attempt at the concept, the Tommy Armour Equal irons.
Right, and this wasn't some custom set for a genius player. This was a mass-produced set where every single iron was the length of a standard 6-iron. They went all in.
They really did. But despite being so innovative, the set was a commercial disaster. It disappeared from the market almost overnight.
So why? Why did it fail so badly? If Jones proved it could work, why did the mass market version completely tank?
A couple of big reasons. First, the golf public just wasn't ready for it. It looked weird, it felt weird, and people were very resistant to changing from tradition. But the second reason is the more important one.
Which is?
The engineering in the 1980s just wasn't good enough to solve the core physics problem that the concept creates.
And what is that central physics problem?
Well, when you shorten a long iron, say a 3 or 4 iron, down to the length of a 6-iron, you automatically reduce your club head speed.
So you lose distance.
You lose a ton of distance.
Yeah.
And to get that distance back, the ball has to launch much higher with more spin.
And in the 80s, without things like high-density tungsten or modern head designs, they couldn't do it.
Exactly. They couldn't get the long irons to fly high enough. So what amateurs found was that their 4-iron went almost the same distance as their 6-iron. There was no functional gapping.
So the simplicity it promised wasn't delivered by the technology.
It was a failed experiment. But the idea didn't die completely. The sources show it survived, sort of, underground.
In the 2000s, right, with niche brands and custom fitters.
Yep. Companies like One Iron Golf,
Mm.
Wish on Golf with their Sterling irons, Adel Golf, Pinhawk. These were the true believers keeping the concept alive.
So the idea was there, the tech was slowly catching up, but it was just for gearheads and tinkerers.
It was. It was missing that one key ingredient to break through. It needed a high-profile, undeniable success story. Someone who could not only win with it, but explain why it worked.
It needed a scientific catalyst.
It needed Bryson DeChambeau.
And DeChambeau really was that catalyst. I mean, he didn't approach golf as an art, he approached it like a physics problem to be solved.
He absolutely did. He started building his own single-length sets in the early 2010s, working with prototypes from Edel Golf. And his motivation wasn't marketing, it was pure academic curiosity about reducing variables.
He saw the same thing Jones did, one setup, one swing, but he wanted to take it to the mathematical extreme.
He did. He didn't just match the length, he standardized 3 critical things across his entire set.
Okay, so what did he standardize?
First, the obvious one, shaft length.
Mm-hmm.
Everything was built to the length of about a 6 or 7 iron, around 37.5 inches.
Okay.
Second, he standardized the lie angle to be very upright, around 72 degrees. And for you listening, the lie angle is just how the shaft meets the club head, and it's critical for a consistent strike.
And that third one is the real engineering challenge, right? The head weight.
That's the one. A traditional 9-iron head is way heavier than a 3-iron head. So when you put them on the same shaft, you have to compensate. He was literally adding lead tape, drilling out material,
Yeah.
obsessive stuff, to make every single club feel identical.
And his argument was basically a modern version of Jones's philosophy.
It was. If you have 13 different clubs, you're learning 13 different swings. One length means one swing, which means fewer variables, more repeatability, and tighter dispersion. Simple.
And the validation came almost immediately.
It really did. In 2015, he wins both the U.S. Amateur and the NCAA Championship using that set. That was the missing piece. That success got massive, inescapable industry attention.
The kind of attention the Tommy Armour clubs never got.
Exactly. And that, finally, was the launching pad. In 2016, Cobra Golf signs him. They partner up, and they release the King F7 one length to the public.
And they've been refining it ever since.
Continuously.
Yeah.
They realized that for this to work for you, for the average golfer, you needed serious engineering to solve those gapping problems from the 80s. And you can see that evolution through their different models over the years.
Okay, let's dig into those mechanics, because this is where the modern engineering really makes the whole concept shine. For the person listening, what are the, say, top 3 benefits of this system for an amateur golfer?
The sources really boil it down to simplicity. First and foremost, you get one setup and one swing.
The core idea.
It's the foundation. It just simplifies the learning process and reduces that mental clutter when you're over the ball. Same posture, same ball position, same tempo every time.
And that consistency in setup leads to what?
Improved accuracy. The whole set is built to the length of a mid-iron, maybe a 7-iron. And for most amateurs, that's the easiest, most controllable club in the bag. So you're basically making all your irons as easy to hit as your 7-iron.
And the third benefit is all about rhythm.
Yes, consistent ball striking and timing. Because every club swings and feels the same, it's much easier to maintain a single, repeatable tempo for all your iron shots. That means fewer mishits.
But as we saw with the Tommy Armour failure, it's not a perfect system. Physics is still physics. What are the big technical hurdles engineers have to clear?
The biggest one is still the long irons. When you make that shaft shorter, you lose speed. And if you don't do something to compensate, they just won't fly far enough or high enough.
And then you have the exact opposite problem with the wedges.
Correct. The sources point out that a wedge built on a 6-iron shaft can feel, well, awkward and clumsy. Until you adapt, you might hit shots way too high or even chunk them because the club just feels too long for a delicate shot.
So this is where modern manufacturing comes in. How does a company like Cobra fix that low-launching long iron problem?
They get really smart with the center of gravity, the CG. To get the ball to launch higher, they have to move the CG in the club head lower and deeper, away from the face.
How they do that?
They use high-density tungsten weights. By placing that heavy tungsten low and in the heel and toe, they basically create this slingshot effect that helps pop the ball up in the air, even with less club speed.
Okay, that makes sense. And what about the other end of the bag? How do they make sure you still have proper distance gaps between, say, your 9-iron and your pitching wedge?
For the short irons and wedges, they play with the static weight. They'll use heavier shafts or slightly heavier heads. That increased mass helps to control the trajectory, bring it down a bit, and it ensures you get that predictable 10 to 12-yard gap between your scoring clubs.
So it takes an incredible amount of specific, complex engineering in each head to deliver that feeling of ultimate simplicity. It is just incredible when you trace that historical line. You see an idea that basically hibernates for 50 years and then just explodes back onto the scene.
To start with Bobby Jones and his custom Spalding set in 1930.
Yeah.
That's the ultimate validation, the Grand Slam.
Then you have the commercial failure of the Tommy Armour Equal, the decades of tinkering by those niche underground brands.
Until the final catalyst arrives. Bryson DeChambeau, who uses modern science and partners with Cobra to finally make the system work for everyone.
But through it all, the core philosophy never changed.
Never. Less complexity leads to more consistency.
And this brings us to a really interesting final thought for you to chew on.
Mm-hmm. Think about this. Bobby Jones achieved the Grand Slam with a very primitive version of this concept. He was focused entirely on his own repeatability to overcome his flawed equipment. Today, to make single-length work, it requires incredibly advanced engineering precision, CG, tungsten, specialized weights in every single head all, to solve the physics of gapping and trajectory. Does achieving ultimate simplicity in the system today require far, far more underlying technical complexity than it did 100 years ago? Something to think about.